Hello everybody and welcome back. Today we are going to be looking at some practical applications of Le Chatelier's principle. So these are just your guided practice problems. There is a link for a copy of the problems on Canvas, so if you wanted to pull those up and fill those in as we go along, you can, or if not, you can just watch this to get some extra practice. You don't have to turn in those practice problems. They are strictly for you to help you get some practice in. Okay, so let's start with looking at some problems where we're changing concentration of either our products or reactants in our equilibrium equations. So just a reminder, adding a reactant or a product shifts the equilibrium away from the increase, and removing a reactant or a product shifts the equilibrium towards the decrease. So what does this mean? So basically, remember, if we're talking about concentrations of your reactants and your products, an equilibrium equation, you want to be in equal concentrations, right? So if you suddenly have more reactants on the left-hand side of your equation, then you're going to want to shift your reaction to favor the products because you're going to want more products to be made until equilibrium is reached and those concentrations are equal again. So let's take a look at some of these problems. So here we have this imaginary reaction. We have X plus Y, which are our reactants, will yield A plus B. It's an equilibrium equation, so there's a forward and a reverse reaction. So it says if the concentration of X is increased, the reaction will shift to the... So let's take a look. Now, if our X is being increased, that means we're seeing an increase in our reactants, okay? So that means we're going to have more reactants on the left than we do have products on the right. Now, if our reactants are up and our products are down, we're going to favor the production of our products because we want more products to be made until equilibrium is reached. So we're going to shift to the right, okay? We're going to favor the production of our products until equilibrium is reached. All right, so let's take a look at another one. Same imaginary equation. So it says if the concentration of Y is decreased, the reaction will shift to the blank. So here we're seeing a decrease in our concentration of Y. So we're seeing a decrease in our reactants. So if we see a decrease in our reactants, that means we have less reactants than we do have products. So if we have less reactants than we have products, we're going to see a shift to the left because we're going to make more reactants until equilibrium is reached, right? The name of the game here is just basically shifting in the opposite direction in order to maintain equilibrium. All right, so same equation. So if the concentration of A is increased, where will the reaction shift? So A is one of your products. So if we are increasing the concentration of a product, that means we've got more products than we have reactions. So we're going to need to favor our reactants in order to maintain equilibrium. So we need to make more of the reactants to bring them up basically to the same level as the products. So if we are making more reactants here to maintain equilibrium, that means we're going to shift to the left. So this one says if the concentration of B is decreased, the reaction will shift where? So B is on the right-hand side of our equation. It is a product. So if we're decreasing the concentration of B, that means we're going to have less products overall. So we have more reactants, less products. So now we're going to shift to where the products are favored because we want to make more products to maintain equilibrium. So we will be shifting this reaction to the right. All right, so those were concentrations. Now let's take a look at temperature. So a reminder, if you add heat, so you increase the temperature of a system, it will favor away from the increase. And if you remove heat or decrease the temperature, it favors toward the increase. So a good way to think about this is thinking about from biology and maintaining homeostasis. So when you get hot, let's say you go outside on a summer's day and it's 100 degrees outside and your internal body temperature raises and it gets too high. Your body its job is to maintain homeostasis, maintain equilibrium. So while your body temperature is rising, you're adding heat, your body is going to produce sweat in order to oppose that change, to bring your temperature back down. So it's going to shift in the opposite direction. Same thing if you remove heat. So if you're going out and it's cold and you don't have a jacket on, you start to shiver, right? Because your body is trying to bring your temperature up. Okay, so if you remove that heat, you are going to, if you have, so a decrease in temperature, your body tries to bring your overall body temperature up, and you can kind of apply that similar thinking and that concept to your chemical reactions, if it's an easier way to think about it. So let's look at this. We've got 2 moles of sulfur dioxide. Oxygen is going to yield 2 moles of sulfur trioxide plus heat. So heat is our product here, indicating that this is an exothermic reaction. Because remember, in an exothermic reaction, exo means out, the heat is being released. So here it says if the temperature is decreased, the reaction will shift to the blank. So if the temperature is being decreased, we're going to want to shift to where the heat is going to be increased in the surrounding area, because we want to shift in the opposite direction. Because this is an exothermic reaction and heat is being released, we're going to shift to the right, okay? So temperature in the surrounding area goes down, and then you have a increase or a shift to the right to produce more heat to maintain that equilibrium. So here's another reaction. We've got nitrogen, oxygen, and heat to yield 2 molecules of NO. And so if the temperature is decreased, the reaction will shift where? So this is an endothermic reaction. And in an endothermic reaction, remember, if the temperature is decreased, we're going to see a shift to the left. Okay? Again, we're just going in the opposing direction. So here's another one. We've got, again, sulfur dioxide plus oxygen to yield sulfur trioxide. We've got a negative delta H, okay? So remember, when delta H is negative, that is your indication that this is an exothermic reaction. So if you didn't know, if it didn't tell you where your heat was, but it did give you your delta H, your change in your enthalpy, remember that a positive delta H is going to tell you it is exothermic, so we can visualize our heat being over here on the right side. So it says if the temperature is increased, the reaction will shift to the left. Now, why is that? Because if we are getting an increase in temperature, right? So if our temperature is increasing and our delta H is negative, this is exothermic. So the heat is being released on the right side, right? So heat is being released just as a part of the exothermic reaction. So if we've got a lot of heat, we're not going to shift to the right to produce more heat. We're going to shift to the left, right? In the opposite way. So here we've got another temperature problem. We've got nitrogen and oxygen again. So the same formula that we were looking at before, but now the delta H is positive. And when we have a positive delta H, that's our indication that this is endothermic. So heat, if you want to visualize it, heat should be on the left-hand side as a part of the reactants because it's what goes into the equation. So if the temperature is increased, now our reaction will shift to the right, okay? Because again, we're just going to go in the opposite direction. So if the temperature of the surroundings area is increased, temperature is going up, we're going to shift to the right in order to favor that opposite direction. Now let's take a look at changes in pressure. So an increase in pressure favors the direction that has fewer moles of gas. So if we see an increase in pressure, so that means we're compressing the area. A lot of times we're talking about gas, right? So if you have a gas in a chamber and you increase the pressure, there's less room for it to move around. So it's going to favor the direction that has fewer moles of gas. It's going to want to move to an area where it's a little bit less crowded. A decrease in pressure favors the direction that has the greatest moles of gas. And then in a reaction with the same number of product and reactant moles of gas, pressure has no effect because you're in equilibrium, okay? So let's take a look. We have a reaction here. We've got hydrogen, oxygen as our reactants, and then we've got water as our product. So it says if the pressure is decreased, the reaction will shift where? So again, if we're seeing a decrease in our pressure, we're going to want to shift to where there's more molecules, so more moles. So here we've got 2 moles of hydrogen gas, 1 mole of oxygen gas, so 3 moles on the left. And then on the right, we've got 2 moles of water. So 3 is greater than 2, so we're going to shift to where there are more molecules, which is to the left. And remember, a mole is Avogadro's number, 6.022 times 10 to the 23rd molecules, right? So it's just a value that you need to look at. So we're shifting left because that's where there are more molecules. And then finally, we're going to consider this endothermic reaction. We've got carbon dioxide, hydrogen gas, heat to yield carbon monoxide and water. So it says if the pressure is decreased, the reaction will shift where? So let's look. We've got 1 mole of CO2, 1 mole of hydrogen, 1 mole of carbon monoxide, and 1 mole of water. So that's 2 moles on the left, 2 moles on the right. So we've got 2 and 2, which means we're at equilibrium, which means there's no shift, okay? And that's how you do that. Just take a look at your coefficients, and you're going to shift depending on if the pressure is going up or down, okay? So I know that's a lot. I know it's been a lot this week. If you're on pace, you should be watching this on Thursday. And then so tomorrow is going to be kind of just like a free day for you guys to catch up with anything that you've missed this week. If you need help with anything, let me know, reach out, send a reminder, send an email, you know the deal by this point with our virtual learning. You do have a virtual lab to do today. I've linked a video below that kind of shows you how to navigate that a little bit. It's not super hard, but again, if you have any issues, let me know. And I hope you guys have a fantastic day, and I hope you guys are all staying safe. I will talk to you guys soon.